Hello and welcome to Trailblazers. This is a series of conversations with Columbia University faculty whose ideas shape our world. I'm your host, Dustin Foote, and today we're talking about the technology behind how we communicate online with Professor Henning Schulzrinne. Professor Schulzrinne is a professor of computer science at Columbia Engineering and a pioneer in the development of internet and video calling technology. His work on voiceover IP helped lay the foundation for the tools millions of people use every day to talk, meet, and collaborate online, from the technical standards that enable real-time communication to public safety innovations like text to 911. His research sits at the intersection of engineering, technology, and public life. Today, we're talking with Professor Schulzrinne about his work and how the systems behind the internet make modern communication possible. Professor Schulzrinne, welcome to Trailblazers.
Thank you.
Many of us use Zoom, WhatsApp, FaceTime to make video calls every day. I wanted to know what your role was in making those things possible, and if you can describe how that technology works.
Sure. So let's rewind a little bit. So when I started on that work in the mid-1990s, the only thing that really existed for voice and video communication were proprietary systems or the telephone system. As in, you had to use their telephone company, whether early mobile phones or your home phone, most likely, or your office phone, for making voice calls. And so it became then technologically possible because we had computers and somewhat faster networks to build voice communication and later video communication that used internet protocols as opposed to the traditional telephone network. All of these applications that you mentioned, such as Zoom and WhatsApp, and in particular the application that you run on your phone, after all, rely on the transmission of voice and video across the internet. And the developments that I participated in were to design the so-called protocols that allow that transmission to occur, and in particular, allow that to occur in a standardized way. So, for example, Zoom, if you look at your typical Zoom invitation that you receive in your email a few times a week, has a whole section that you have 3 ways to participate. You can have a proprietary Zoom app, you can dial in by a traditional phone, or there is a URL mentioned at the bottom, which is typically used for room system, called a SIP URL. And that URL is used to connect in an interoperable way, even though you may not be using a proprietary Zoom client, to connect to that conference. That protocol that's mentioned in the bottom of that Zoom email is the one that I worked on.
I'm interested to hear what got you involved in this field in the first place.
Yeah, so I had been a graduate student, and we were working on a project actually supervised by a Columbia alumni, a faculty who got his degree here at Columbia at UMass, and they had an DARPA project that I was trying to look at more modern mechanism of transmitting real-time information, meaning things that have a deadline, across the emerging higher speed internet. And I got involved and built one of the first applications to transmit audio and video across the internet when internet speeds were much, much lower. PCs didn't have sound cards. You had a workstation on your desk.
Was there anything particular about the internet that drew your attention?
At that time, conventional wisdom was that you had really 2 different networks, namely the telephone network and the emerging internet. And the short version was the internet was for text like email and file transfer, and the telephone system was for largely voice. So the telephone system was great at transmitting voice at decent quality, cheap, anywhere you wanted to go. And the internet was great for downloading files or sending an email that was largely text-based. The challenge at the time was, and that continues today, is that the so-called quality of service of the internet, the predictable delay and packet loss that you might experience or might need for good quality voice and video calls just didn't exist. And so that was the challenge. How can we make, even in an internet environment that was low speed, unreliable, make voice and video work well enough so that it could be used for real collaboration, for transmitting event video, for example, all things that were traditionally done by either TV or radio or the telephone network.
And as you were doing this research, what drew you to Columbia?
So I had been working on internet real-time communication for a few years at that point, and was just transitioning from a position that I had at a research lab in Germany, where I'd worked for 2 years on related topics. And so I saw Columbia as an environment that had a strong tradition of telecommunications research. So, for example, in our field, a renowned researcher, Misha Schwartz, who is considered one of the founders of modern digital communication and worked in an electrical engineering department. So at the time, when I joined and when I applied for a faculty position at Columbia, it was a Center for Telecommunications Research here at Columbia, a National Science Foundation funded research effort, which seemed like a perfect location to find colleagues to work with and to find a hospitable environment. In addition, Columbia had, at the time in particular, the unique advantage that it was geographically positioned just between IBM Research and Bell Labs. So you could, within an hour plus drive, you could work at Bell Labs, and I had an affiliation with Bell Labs. I worked at the Murray Hill facility for a while, and I had colleagues at IBM Research as well.
So can you talk to us about Bell Labs for those of us in the audience that don't know what that is?
So Bell Labs is one of the unique research institutions that is essentially a university funded by, or was at the time, a university-like research setting funded by a private corporation. So at the time I was there, it was run by, or it was part of, AT&T. AT&T at the time had two broadly speaking businesses, namely they obviously provided telecommunication services, long distance and mobile services, as well as a equipment manufacturing business. So they made anything from computers to, in particular, telephone switching gear. So they operated a very large multi-site research lab that did research in anything from astronomy. They got a Nobel Prize, for example, for the discovery of background radiation, the Big Bang, because it was radio astronomy related, to the invention of the transistor in the 1940s, to the invention of modern cellular communication. So many of the things that are telecommunication adjacent, but not only, were invented at Bell Labs, primarily at the Murray Hill location that I had the privilege of working at.
You talked about the partnerships between, basically the private sector and universities. I'd love you to talk about your work and the relationship between the academy and the government.
Certainly. So one of the unique advantages, which I did not appreciate when I started working at Columbia, is the willingness of the university to allow faculty to collaborate with government institutions. And this happened in my case in two ways. Namely, one, it became clear after I had started working on voiceoverip in general that there was a real opportunity to modernize one aspect of primarily voice communication, namely emergency calling, 911. So emergency calling, a function that most of us hope we never have to use, but we rely on and is a vital part of our public safety infrastructure, had really not progressed much since the 1980s, when it was bolted onto a digital network in a way that provided some rudimentary functions. And in collaboration with government and industry partners, I was able to help modernize the 911 system, what's now known as NG911, Next Generation 911. For example, New York City just started using that for their main 911 system. So that motivated me, now that I had been working more with governmental partners and industry organizations that specialize in that particular field, to do a sabbatical at the Federal Communications Commission in Washington, D.C., so that we could transition the technology that I had worked on into government rules and regulations, encourage the transition from a prototype to a widely available system. So there, I ended up working as a researcher initially on a short-term leave with the public safety and homeland security, starting the modernization process for emergency calls, in particular to implement text to 911, the ability to send text messages to literally digit 911, which you can do now in many locations in that.
I was curious because I read about this 911 calling and how you helped shape the service for people with disabilities. Is the text to 911 part of that?
Text to 911, I sometimes compare it to the curb cuts that you find on sidewalks, as in the initial motivation was for making 911 calls available for people who could not easily speak to 911. So primarily people who are deaf, so who often have difficulty, certainly hearing, and have difficulty speaking in some cases. And so they had really no good way when they experienced an emergency to reach help. They would have to go through a relay service, usually delayed delivery. It was indirect. There was somebody in the middle to do it. They had to be at the right kind of terminal because it had to be a video-capable terminal, often to do sign language. And so the initial motivation was we need to support those communities that have communication disabilities to reach a literally vital service. Pretty quickly, it turned out that there are quite a few situations where people, even though they, in theory, could make a voice call, find it easier or safer to text. So one common scenario are domestic abuse situations, where either a witness, such as a teenager, or a spouse that is being abused, does not feel safe to make a 911 call because that's clearly audible to the victimizer, and finds it much safer to text, which you can do more surreptitiously in that. So situations where it is unsafe to place such a call. And it also turns out that in some cases, people are just reluctant to make a 911 call, and they feel more comfortable just texting. So that has turned out to be not a very common but quite helpful modality when voice calls are either not possible, or when they feel unsafe, or when people are just not able to do that. In some cases, and I don't know how common that is, you can sometimes make a SMS text message work even when voice does not work because you're too far away, you're in a basement somewhere where voice reception is poor. So there are situations, again, generally at the edges, if you like, where text messaging is much better than a traditional 911 call.
What are other issues that you see on the horizon in the next 5 to 10 years that you think are solvable?
One area where I believe a need has arisen is for cybersecurity for so-called embedded devices, the Internet of Things. Now we control so many of our vital functions, whether that's water treatment plants or whether that's air traffic control or energy distribution or transportation, are all now controlled by internet-connected or internet protocol-enabled devices. So suddenly, remote attackers have the ability to interfere with operations of vital support systems that we all rely on without having to have physical presence. We know largely how to secure such systems in theory, but we have failed spectacularly about creating incentives and broad-based systems to get those systems deployed, to test those systems, to validate and verify their operations. So all of these three areas are really in need of continued application-driven research that allows us to then mandate the deployment of those systems in a way that we can rely on, we can predict, and operators that are often not in the technology business. My water treatment operator is not an IT specialist by training or by industry, can rely on those systems to function even in the face of attack or disruption.
All right, so we like to end these episodes on a light note. So with that in mind, I have one final question for you, which is, what is a piece of pop culture, a movie or a TV show or novel that actually gets something right about your field or hilariously wrong?
I say a general one is almost all hacker movies are just hilariously wrong. As in, you see some hacker sitting at a green screen terminal and magically breaking into some fortified system in there. And that's just not how things work in modern real life. So that, I think, gives the fundamentally wrong and misleading impression what our challenge is.
Well, Professor Schulzrinne, thank you so much for taking the time to talk with us today. I really appreciate it.
Thank you for your interest. I appreciate it.
Trailblazers is a production of Columbia University's Office of Public Affairs. You can listen to our other conversations on Columbia's Impact and Innovation website, our Vimeo page, or our YouTube channel. Thanks so much for listening.